This is theCUBE. I'm Paul Gillin, and we are celebrating World Quantum Day, an annual event raising public awareness and understanding of quantum science and technology around the world. You can check out more at worldquantumday.org. It's a very exciting time in quantum computing right now, with commercial models beginning to reach the market, multi-qubit quantum computers in labs, a potential revolution in computing, really. Here to tell us about his part of it is Dr. Mikael Johansson. He's the manager for quantum technologies at CSC, the Finnish IT Center for Science. Dr. Johansson oversees CSC's participation in global initiatives related to quantum technologies and in general explores and enables the uptake of quantum technologies in R&D communities. CSC actually does not currently have a quantum computer, but it does have one of the world's fastest supercomputers, a Cray model, that it is combining with a quantum computer at the VTT Technical Research Center of Finland to make it available to European researchers. Now, this hybrid approach will enable these researchers to test the limits of both architectures. And Dr. Johansson, thank you so much for joining us today.
Thank you for having me.
So how does the LUMI-Q Consortium, first of all, tell us about the LUMI-Q Consortium. What is that, the objective there?
Well, the LUMI-Q Consortium, so that's one of these EuroHPC efforts where the European Union has funded several projects to really drive forward this hybrid method of computing where we combine classical supercomputers with quantum computers. And LUMI-Q is one of them, and CSC is part of the consortium that is setting up the service of where we really want to give European users the opportunity to start testing and experimenting with quantum computing and really figuring out what use they will have in the future.
How difficult is it for researchers to get access to quantum computing outside of your efforts?
I would say that it has been or become much easier in the latest years. So there are several cloud providers already providing access to quantum computers. So it's not that difficult. I think the barrier is more in getting users to find out what quantum computers are useful for. But within the EuroHPC efforts, like LUMI-Q, so there the focus is really on this hybrid computing and figuring out where we can combine the power of classical supercomputers, HPC, and quantum computers and make them work together in an efficient way to really solve problems that one could not solve before with either technology alone, neither classical supercomputers or just cloud quantum computers.
Well, I think there is confusion among those of us who are not quantum experts about what exactly quantum computers excel at. Can you give an example of a type of use case where a quantum computer is able to achieve orders of magnitude better performance than a classic supercomputer?
Yes, so quantum computers, so they operate fundamentally at a completely different level than classical supercomputers that are restricted in a way to this man-made, human-invented logic of zeros and ones. So quantum computers use quantum logic in their mathematical operations, and that makes it possible to solve certain types of mathematical problems, for example, in a much more efficient manner than if one would be using classical logic. And already from the beginning, when one came up with the idea of quantum computing in the shift of the 1970s, 1980s, then one of the first applications that one thought up for these new machines that didn't exist at that time was to really probe and explore and investigate the quantum world. And the quantum world, that's of course a very, very broad concept, but concretely it involves studying how, for example, electrons interact with each other. And that's, again, the basis for chemistry in general and material science in a broad sense, to really know what happens at the atomic scale and sometimes even smaller. And that's something that classical computers really struggle with when they try to solve these very complex equations, at least when one needs high accuracy, which is needed for several types of problems. And here, quantum computers really have the potential to make extremely powerful breakthroughs. And if you, for example, take just the green transition as an example, we could design better catalysts and develop next generation batteries and magnets that are very central, of course, to modern society. And this is really where the type of materials challenges where quantum enhanced simulations can come to real breakthroughs. And it's also this type of problems where quantum computers can make a real difference. And it's by solving the problems in a way not by brute force methods, but solving it in a more natural way, just because the problem itself is inherently quantum mechanical. So that I would see as one of these near-term breakthroughs that quantum computers really can drive.
The LUMI-Q Consortium is making supercomputer, Cray supercomputer, and quantum computer resources available. What is the significance of having both of those available to researchers? How are they applying the two together?
Well, as I said earlier there, so quantum computers can be very efficient at solving certain types of problems, but there is still a large category of problems that really will not be performed better if you have a quantum computer. So in any sort of real world problem solving or real world application where you have a larger problem, a modeling problem that you want to solve, and there is a big need still for classical supercomputing, and that's not going to change. So it's more of finding those bottlenecks in classical HPC and then identifying those and then figuring out if by using a completely different quantum logic one could find solutions that are more efficient. That's why we are going to need both the raw power of supercomputers for a long time, if not forever, and then enhance their operations by really offloading some of the most complex equations for quantum computers, if they are suitable for quantum computing. Not everything is, of course.
You mentioned earlier the value of quantum in modeling interactions between atoms, for example. How about in a more commercial realm, such as in pharmaceuticals or in finance? Are there areas there where quantum can be a game changer?
Yes, definitely. So pharmaceuticals, so that's then maybe the next level of this molecular modeling. So it's a specific application field of, let's say, quantum chemistry, where we really need to figure out how drug molecules, for example, interact with receptors in our proteins and how drug molecules actually work. And that's also inherently a quantum mechanical problem, to really figure out the interactions between these small molecules and larger molecules within our cells, within our body. So the problem itself is still basically a quantum mechanical problem. It's just the application field that of course then has more impact, or at least is a very specific field where quantum computing in the future can have an impact. So definitely pharmaceutics, if you want to look at the drug efficiency, efficacy, and so forth, will benefit greatly from quantum computing. And again, from the point of view of solving the original idea of quantum computers, which is quantum mechanical problems. But the palette of problems that quantum computers really are good at has extended quite much in the 40-50 years since the original idea came, and general optimization problems are now also seen as very amenable for quantum computing, and here, of course, financial risk analysis and portfolio optimization are often taken up as examples where complex optimization solutions really can have an impact. So there's definitely plenty of commercial use for quantum computers, but we are maybe not there quite yet.
Do you see quantum technology infusing itself into other mainstream commercial computing technology to the point that someday you'll be able to buy a quantum computer or a quantum powered computer off the shelf?
Well, but one should maybe not make predictions too far into the future. There's the famous quote that no one is going to need a quantum or a normal computer at home either. But I think that for quantum computers, because the technology will for a long time require quite much space to operate. So, for example, presently one of the more successful technologies on how to construct quantum computers depend on having very low temperatures, close to absolute zero, and just the refrigerator or the cryostat that can cool down your quantum processing unit, the QPU, to almost 0 Kelvin takes a lot of space. So and is also very expensive. So at least I would say that for the foreseeable future, you will not have a quantum computer at home, and you will not buy it off the shelf. So it is specialized hardware that in a way the same way that the supercomputers are specialized hardware. So even if they are based on very much the same technology as your laptop, then you're still not going to have a supercomputer that is the size of a football field at home.
Is there a global race on for quantum advantage?
Yes. I think there is, and I think that's a good thing, because I think in recent years we have moved from this theoretical idea of a quantum computer in theory being able to solve some problems much more efficiently than classical computers to really now being at the doorstep of true quantum advantage, where quantum computers do provide solutions more efficiently or using less energy or then more accurate solutions. And there is still a need to really develop the software and come up with algorithms and problem classes that could exhibit this quantum advantage. And having a healthy race here is, I think, very good for the field in general. So, and I think it is being fueled by the promise of quantum computing having a real breakthrough in the coming years.
So, what benefits would accrue to Finland or to Europe having a lead in quantum computing?
Well, I think for any nation or a larger area, having a lead in technology is good for economy, but I think the most important part is that one is up there at the top and really understands these technologies and understands what it's good at, and has the competence to really develop both the hardware and the software of a new breakthrough technology. Because, well, obviously having, let's say, the best quantum computer available on the market is good for economy through sales, but I would say that even more important is having the skills to utilize the new technology and really use the technology for solving some problems that are really impactful and have wide societal benefits. So and this comes through being and keeping oneself at the top of the technology and really understanding how it works and but even more than understanding how to actually use it.
As you know, there are many different architectures for quantum computers right now. Do you see one emerging as sort of the standard, or will we continue to have a diversity of approaches for a long time?
Yeah, I think we will have diversity for a long time, and I think that is very healthy. So announcing a winner in the technology race, for example, on the way of constructing qubits it's much too premature at this stage, and most likely one will have a future where different types of quantum computers will be good at solving slightly different types of problems. So I think it's necessary to not lock down on a specific technology or even a few technologies, but to really explore many different ways of implementing quantum computers, because we are still at a rather early stage, and it might be that some technologies will face scaling up issues along the road, and then already for that reason it is important to have several alternatives to fall back to or to develop in parallel, I would say. And so no, we do not have a winner yet, and we probably will not have one single winning technology for a very long time, if ever.
Do you foresee quantum having a sort of a chat GPT moment where the consciousness, the awareness of the technology explodes, people see a real practical value to it, or is this more of a niche approach, small niches of different industries?
Yeah, I would not say that it's a niche approach, but even if the types of problems that quantum computers are good at is maybe rather specific, but at the same time, those areas will have utility in a very broad field of applications then. So we mentioned pharmaceuticals there already, and materials science and optimization, and all of these methods are of course something that is used very broadly across several disciplines. So in that way, it's not going to be a niche technology. But regarding the ChatGPT moment, so I think what we will see is a steady increase in the capacity of quantum computers. So there's not going to be a step function that now suddenly quantum computers do something very much faster than before. So we don't have this moment that in the field of traditional large language models and ChatGPT AI. So that step moment came from the capacity to suddenly be able to analyze much larger amounts of data than before. But here it is more of improving the hardware, improving the quantum computer capacities, and they will continue to steadily grow in performance, and which means that we will first see a bit of incremental performance for some problems that will continue to grow then, and then also the applications field, so they will grow one by one over time. But I don't think we will have the same type of ChatGPT moment, except maybe in the way that suddenly when the first real quantum advantage is demonstrated, then it might come as a surprise to people who were not looking into the field before, and in that way, more of a wake-up call that, okay, now at least it's time to start investing in quantum computing.
And so what's ahead for CSC and for LUMI-Q? I understand CSC is getting a quantum computer next year.
Yes. So LUMI-Q was the EuroHPC project where the quantum computer actually is located in Ostrava in the Czech Republic, hosted by IT for Innovations. But we are now in the middle of setting up the LUMI AI Factory, which is one of the several European AI Factory initiatives. And for the LUMI AI Factory, we are also integrating a quantum computing platform there called LUMI-IQ, and that one will be hosted in the same data center as the actual supercomputer, the AI supercomputer. So that's something that we are very much working on right now. So we are, as we speak, we are in the middle of negotiations for both the classical supercomputing platform and LUMI-IQ quantum computing platform. But the goal is anyway to really set up from the beginning a tightly integrated platform where end users can explore the combination of AI, classical AI and quantum computing in a completely new manner. And we are very much looking forward to see what our end users come up with for use cases and other developments there. So we are very, very happy to provide this infrastructure for the European community and, of course, through collaborations on a more global scale.
Well, Dr. Mikael Johansson, you certainly are in an exciting place at the intersection of the leading edge technology. Thanks for taking some time out to tell us about your experiences today.
Thank you very much. It was a pleasure.
This is Paul Gillin. This is theCUBE. It's World Quantum Day that we're celebrating. Thanks to Hewlett-Packard Enterprise for their sponsorship. We'll be back with more.